Now, once we have got Docker installed, then the basis of everything within our Docker container system are images. Images make the basis, the platform from which we clone our virtual containers. Our containers are runtime copies of our images. We only need one image, but we can have multiple containers running from that image. When we look at the command, we can see then it's going to be our Docker image command, and we can gain help, or we can look at the man pages. We can list our images. We can go through and look at the metadata relating to an image. We've already got our Hello World image, and we're able then to go through and look by filtering on the repo tags. Tags are really the name of our image. We can add another tag to that image, so we could call it My Hello. So it'll be available as Hello World and also My Hello. When we go through and take a look at our images, we'll see now we've both images, but they are pointing to the underlying same data file. When we go through and take a look, we can locate those images themselves underneath var, lib, and docker. To locate images, we can use the Docker search command. Here we're looking for the Ubuntu image. We can add on filters. Here we're adding in the filter is official equals true. So of course we're only going to be displayed official images that are coming from the vendors themselves. Now of course there are other commands that we can use, and it's best that we just dive out to our command line and actually get some hands-on practices working with Docker and images. Come on, why don't you join me? And here we are. Look at this, our glorious Ubuntu 2 system. Now, we've already got Docker up and running on this, and we're going to start playing around a little bit more with the Docker image command. Now, we can begin with the older command, Docker images. This does give us a very simple and quick way to list our images, but it's not written in the newer style where they organize commands around the object they're working with. So Docker image ls is now the preferred way of doing it. Of course, it makes no real difference, but the idea of organizing our commands also then gives me the ability to use tab completion to see what commands are associated with images. So I can use Docker image and tab, and I can see the subcommands that are available to me. So it really does make a little bit more sense trying to organize our commands under subcommands. We can always look at the help, so minus help for a particular subcommand, but we also have man pages. So if I look at man and Docker dash image, and then we have subcommands, image import, image inspect, image load, image ls, and so forth. If I look at the image ls, it shows me then how we can use the image ls command to list our images. Always try to remind yourself of the help options and the man page options. So if you're ever stuck in real life or in the exam, then at least you have got the documentation that is close at hand and familiar to you. If we go back up though, looking at my Docker and image, we can look at image inspect. With each image, we do have metadata that describes the image. When I go through then and look for the image Hello World, this is the image that we've worked on so far to print the details to the screen, we're able to see that we have got a lot of metadata that relates to it, perhaps a little bit too much. But don't worry, we can go through and search for the elements that we want using the -f. When we filter, we can then go through and specify the JSON elements that we want. And here we're going to look for repo tags, which are really the names of our images. And we can see at the moment it's just got one name, Hello World, and we're at the latest version. So we can separate the name from the version using the colon. It's in a list, so we can have multiple names. Lists are shown by our square brackets. If I use the image tag, we can then proceed to add another tag. So we can tag Hello World with, let's say, my-hello. Tags are really like hard links in our file systems. They're just multiple names pointing through to the same metadata and same data. Now, when I read my repo tags again, we can see that it's both hello world and my hello, with multiple names pointing to the one set of metadata, which of course then points to the underlying data. When I use the image ls, just in the same way as ls in the file system would list both files, we see both images, hello world and my hello. But they've got the same image ID, the same created date, and of course the same size. Also, the size here tells us how small containers can really be. A container only needs the elements that's physically needed by the runtime inside of our container. Here, we only need the executable that prints the data through to our screen. Images, along with their metadata, are stored in the var file system. So I'm able to go through and look in /var, /lib, /docker. And we can look where the name, and then just include the image ID. So we can go through and cut and paste this down, and then just put the asterisk. So we say this is the start of our file name. And we can see then that the image ID is just the beginning numbers. It goes on a little bit, but we have then a metadata file and a content file. So the content that is the actual image, the metadata, just the data about our image. So this is giving you a little bit of understanding about what images are. If we want to locate our images, we can use Docker and search. Continuing our search, we can look for Ubuntu images, and we are searching the registries where images are located. We're able to see the Ubuntu image at the top, but we have Ubuntu Nginx as well, Ubuntu Squid. If we want to look at official images, we can use the -f to filter again, and then isOfficial equals true. So we've got a smaller list of images that we can now go through and work with. Official really means that it's been put up there by the vendor of the product themselves. So it gives us a little bit of an idea of the quality of the image, but also the amount of stars associated with the image are probably going to be the best indication of quality. If we want to pull an image, we don't have to wait until we run a new container. We can pull them ahead of time. So we can use sudo and docker pull. If we pull then that Ubuntu image, and then the image will start coming down. As we then start looking at this, the image comes down. It usually comes down zipped up, and it's been extracted. We can go through then and look at our Docker image and ls. And we can see, well, this is a little bit larger, not too huge, 77.8 megabytes. But also we can have services installed inside of our operating system as well, maybe like a web server or maybe like a database server. So we can go ahead and then maybe look for a MySQL database. But a shortcut that we can create is to alias Docker as sudo docker. So if we just use the docker command, we're going to be executing sudo and docker. It's going to make our command line just a little bit more simple. So I could use docker image ls, which is then running sudo in the background. We could use docker image and pull and MySQL. But because I've now got the alias, we're running the sudo automated through our bash alias process. Now here we can see there are multiple layers coming down. The idea of creating layers in our image means then that we can build up an image and perhaps share components if the early elements, the early layers of an image are the same between different main images. Now that we've downloaded this, of course, we can go back and list our existing images, and we can see now this has really bumped up the size quite a bit, going from 77 meg through to 538 meg, having MySQL installed.